All right, and so this will be the third video for week 7. So far we've talked about the partial derivative and its algebraic definition and geometric definition. Now I'm going to spoil the fun that we had in those videos, and so instead of computing limits, there are actual shortcuts to do these things, okay? The idea is that if we want to find the derivative of a partial derivative of a function, with say, let's say with respect to x or whatever, all we need to do is treat the other variables as constants, okay, and use regular differentiation rules, okay? So that is to say that if I'm finding the partial derivative of f with respect to x, okay, and just to rewrite this a different way, this is 4 minus x squared minus y squared, okay, I treat 4 and y as constant, and I just end up with minus 2x, and then consequently if we were to evaluate it at the point that we used in the previous examples, we would get minus 2. Okay. Similarly, if I want to find the partial derivative of f with respect to y, okay, again, now I treat 4 and the x squared as constants, and constants differentiate to 0, and I just end up with minus 2y. Oh, isn't that fun? Okay. And so even more complicated functions, we can do these kind of quickly. All right, so f sub x, right? Now I'm thinking of, okay, so here's an x, so I have to do the product rule, right? Okay, so let's do 1 and then d2, so cosine xy times y. Remembering the chain rule, right? We might have to review some of those rules, and then product rule. So now I do sine xy, and then the derivative of x is just 1. Okay, great. That's the derivative of the first part. And then for the second part, y is a constant now, right? So I differentiate e to the x, so I have y hanging out front, and then I have e to the minus x squared, and then by chain rule, I have to multiply by minus 2x. Okay, and if you feel so compelled to simplify that further, please do. Okay, I am going to skip it. Similarly, f sub y. Okay, now x is just constant, so the x is going to hang out front, and then I have to do the derivative of sine since y is inside, so cosine xy, and then I have to chain this, so I actually end up with another x, so I get x squared. And then lastly, if I'm taking the derivative of this last part here, y and then e to the minus x squared, e to the minus x squared is constant times y, okay, it's just going to be the constant, e to the minus x squared. All right, and so feel free to use the regular differentiation rules, just remembering that whatever variable you are not differentiating with respect to is constant.